Parallel and perpendicular lines. We're going to talk about their slopes, their graphs, and their equations. By the time we're finished this lesson, you will understand that parallel lines have the same slopes, and you will remember, hopefully, that parallel lines never intersect. We'll learn that perpendicular lines meet to form right angles, and that perpendicular lines have negative reciprocal slopes. We'll learn more about what that means as we move forward. We have the line y equals 1/3 x plus 3. Well, this line is going through the graph at this point 3 right here, and it's moving at a rate of 1/3. So it moves up 1 and over 3 to get to its next point. Up 1/3. And I can go backwards as well to get to the rest of the points. And I can draw my line. If I have another line, let's say y equals 1/3 x minus 2, that line is going to go through at -2. But it is still going to go through up 1/3 in order to get to subsequent points. These lines will never cross because they are always moving at the same rate. They're always moving up 1/3, up 1/3. They'll never cross because they're always moving at the same rate of up 1/3. So they'll never bend and intersect. That is why parallel lines never cross. At these two lines, we have a red line and a blue line. What is the slope of this red line? Well, you've learned how to draw a slope just by looking at a graph. If we look at our rise over our run of this red line, in order to move from an existing point to another existing point, we would start here and move up 1/2. So we rose 1 and we moved over 2. And both were in the positive direction. So our slope of the red line was 1/2. What was the slope of our blue line? We can pick any 2 points. And remember to always pick where it crosses the grid of your graph. I moved up 1/2. So these two lines are never going to cross because they're always moving up 1/2. They're moving at the same rate. They'll never cross each other. Having this information makes it easy to determine if two lines are parallel just by looking at the equations. Now, something to note, this symbol right here is the symbol that I'll use from now on to represent parallel lines. I don't want to always have to write out the word parallel. I'll just use that symbol. And you'll see that a lot in mathematical writing. You'll see those 2 marks that represents parallel. So, in order to look at equations and determine if they're parallel, you'll need to put those equations in that form of y equals mx plus b. Remember, I told you you're going to see that a lot. So you need to be really good at putting your equations in y equals mx plus b form. Once you have it in that form, you can just compare the slopes. And since we know if 2 slopes are the same, then your lines are parallel. So if you compare the slopes and you have identical slopes, then you'll know they're parallel. So let's try it. Let's take a look at these 2 equations and determine whether or not they're parallel. So let's convert both equations into y equals mx plus b form. The second equation is already in y equals mx plus b form, but the first equation is not, so I need to move it around. So let's start with 6x plus 2y equals -24. The first thing I need to do is relocate that 6x. I need to get it over onto the other side of the equal sign, and it needs to be sitting right there, immediately after the equal sign. So I'm going to subtract it from both sides, and I'm going to insert it right in there. And next I'm going to divide everything by 2, because remember the y has to have a coefficient of positive 1. So now I have my equation in y equals mx plus b form, and I can compare it to the other equation, which was already in y equals mx plus b form. And I can look specifically at the slopes, and I ask myself, are they the same? No, they're not. And since they're not the same, they're not parallel lines. They're going to eventually cross, because the bottom one is moving up and over at a rate of up 3 and over 4. But this equation is moving at a rate of up 3 over 1, and eventually they are going to cross each other. Let's try it again. Let's see if this set of equations are parallel. Again, the second equation is already in y equals mx plus b form, and we just need to convert the first equation. The 6y is already where it needs to be sitting immediately preceding the equal sign, and I just need to move the 2x. So I'm going to subtract it from both sides. And I'm going to insert it immediately following the equals. Next, I need to divide everything by 6. Notice how I went ahead and I reduced my slope, all in one step. So now I can compare my two equations and look specifically at my slope. I have the same slope. I have negative 1 over 3 for both equations. I have a negative 1/3 slope. So yes, these are parallel. They're moving at the same rate, and I can see that just by looking at the slopes of their equations. Now, being able to write equations of parallel lines, that's pretty powerful stuff. If you know the slope that is required, you can write multiple lines that follow along the same path. All you need to do is know your slope and know what point you want to go through. It's really fairly simple. You just follow some steps that we're going to outline, and you can do it. These are the steps. Determine the slope that you want to match. Since you know you want it to be parallel, then you just look at the line that you're given and you match that slope. Then you find the point that you want to go through and you plug that in and write an equation that contains that point. I'm going to show you how to do it, but I wanted to list the steps here so that you would have them. How easy it really can be. So we want to write an equation for a line that contains the point 5, 1 and is parallel to y equals 3/5 x minus 4. The first thing we've got to figure out is what slope do we need to match? Well, this equation, conveniently, is already in y equals mx plus b form, so we don't have to convert it. But you know how to do that. You've had lots of practice. So if you had to put it in y equals mx plus b form, you could do it. But this one's already done, so you don't need to. The slope that we need for our new equation needs to match this because we need it to be parallel. So the slope we need to use is 3/5 because it has to match the one we're given. We want our line to be parallel. Let's go ahead and graph this line. Let's just see what this line looks like. This line starts at negative 4. So 1, 2, 3, 4. This is a weird graph. It's hard to do. I'm going to graph negative 4. And it goes up 3 and over 5. And I'm going to go backwards. Okay, and I don't have a straight edge, and I can't use a straight edge on here, so I'm going to have a bad line. So those of you that have me in class, can just scold me later. Okay, now let's finish finding our equation. So the slope we need to match is 3/5. Now, we know that we want our point, or our line, to go through the point 5, 1. So let's mark that point. We know for sure we want our line to go through the point x, or x of 5 and y 1. So we definitely want to go through this point right here. So let's just put that on the graph, and let's just leave that sit there, and let's make sure that our line goes through there. So what we need to do is plug that point into y equals mx plus b, so that we know that that point is in there. So let's take y equals mx plus b and plug in everything we know. We know that we want our y to be a 1. We know that our slope needs to be 3/5. And we know that our x needs to be 5. The only thing we don't know is where we want it to go through the y-axis, or b. So we have an equation with only one unknown, and we can solve for that unknown. So let's go ahead and do it. 1 equals 15 over 5 plus b. 1 equals 3 plus b. b equals -2. Wow, we got a -2 for our resulting b. So now we can write y equals mx plus b using our b and our slope. Y equals 3/5 x minus 2. There is a line parallel to the other line with the same slope, and it's going to go through 5, 1. Let's just see. I'm going to y-intercept of -2, and it's going to go up 3 and over 5. Oh, look at that. I came right in at 5, 1. And draw the line. I go through the point I wanted to go through, right here, and I am parallel to the other line. Perfect. So I think we understand parallel lines. We understand that they have the same slope and they'll never touch because they always are advancing at the same rate up and the same rate over. Let's move on to perpendicular lines. Continue the lesson by going to the link for part 2, which covers perpendicular lines.